So here's section 5.1, exercise 64. And in 64, I have y equal the natural log of the absolute value of secant x plus tangent x. Now this looks pretty nasty. Definitely, I have some issues when x is positive and x is negative. So, and there's no real nice way to deal with this. If I just do y prime of x, well, it's 1 over whatever's inside, and then times the derivative of whatever that was. Well, what's inside is this absolute value of secant x plus tangent x. So that part, but now the derivative of that thing, so secant x plus tangent x, absolute value, like that. And yeah, that looks kind of nasty because, again, an absolute value, that's a piecewise defined function. See, so we have our function is secant x plus tangent x whenever that is greater than or equal to 0. So I would just have to write it that way because I don't know when that, I mean, I can work on that, but for right now, I'll try to get that x in there. That's greater than or equal to 0. And then it's the negative of all of that, secant x plus tangent x, when that expression is less than or equal to 0. So, I can work on that. I can go in here and say, well, okay, when is it equal to 0? So when is secant x plus tangent x equal to 0? Well, secant x, remember, is cosine. So this is, or 1 over the cosine. So this is 1 over the cosine of x plus sine of x over the cosine of x is equal to 0. Oh, well, actually that's helpful because I can factor out the 1 over the cosine. So I've got 1 over the cosine of x, and then that's times 1 plus sine of x. Well, this is much simpler for me. Now, this is undefined, of course, when cosine of x is 0. So this is undefined. This expression on the left is just undefined when x is pi over 2 or minus pi over 2 or something like that. And then we have when sine of x, we actually get 0 when what? When 1 plus sine of x is equal to 0, or sine of x is equal to -1. Well, that x would be things like minus pi over 2 or 3 pi over 2 and so on. Now, this doesn't list a domain, and so it really is, it's however we want to write it. I guess I would probably write it as x equals minus pi over 2 plus 2k pi. So every time you go around one direction or the other, you would get 0. And then the question is, well, okay, is it positive or negative in between? And we can look at that. Now, what I might do instead is you know, way back here, actually just kind of look at that function. Um, so go to the web. I have a graphing calculator here, and so I can look at, and I don't know, I'll call it maybe f of x. So I have f of x is equal to, now I'm not going to use the absolute values because I'd like to know where it's positive and negative, and then I could always do the absolute values if I wish. But that was secant x plus tangent x. So I can go to my functions here and do a secant x and then plus tangent x. And so this is what it looks like. And so we're positive, you know, from this point, what is that point? Minus 1.571 looks like minus pi over 2, right? And then 3 pi over 2 is this vertical asymptote here. So it's interesting. Notice that we have what appears to be at the minus pi over 2, and then oh yeah, so I'm sorry, yeah, this is minus pi over 2, and then we have the asymptote at probably pi over 2, and then again at 3 pi over 2 we have what looks like a removable singularity. So that's kind of neat. Now the function's still undefined here, but you know, the limit is such that it seems to work, which is kind of interesting. I'm surprised Desmos has given us an answer, but it must be it likes the limit, because otherwise, you know, these things are not defined here except in the limit, and I'm actually quite surprised with Desmos, but at any rate, so we would have this nice derivative in here, and you know, we'd have the positive function out in this area, you know, places like that, and we have the negative in here, so we'd have the absolute value. And of course, if you do the absolute value, you're going to get a corner at this point, and so the derivative would be undefined. Okay, so let's see. So we want that derivative. So I guess I can just take that derivative as long as I'm in between my minus pi over 2 and pi over 2 and etc. And so going back to all that, I'm just going to go ahead and do that derivative, that absolute value part. And but first, I just want to, well, I guess just to take up less room, I'm first going to just take the derivative of secant x plus tangent x with respect to x, and that is, well, secant, if you look that up or derive it, that's secant x tangent x, and then plus derivative of tangent is secant squared x. And so that derivative, when we're in the positive areas, then we get that for the derivative. When we're in the negative areas, we'll get the negative of that for the derivative. And so this just gets to be a royal pain to try to write this derivative down. Right? We've got y prime of x is equal to, our denominator is the absolute value of secant x plus tangent x. And the numerator, well, is, it's either going to be a plus or a minus secant x tangent x plus secant squared x. Okay, that plus or minus depending on what interval we're in. And so we could pin those down. Again, it's going to be, well, I got to go back and look at it, I guess. So it's going to be positive between minus pi over 2 and pi over 2. And it's going to be positive again at 3 pi over 2 and 5 pi over 2 and so forth. So, you know, it's the plus when minus pi over 2 is less than or equal to x, less than or equal to pi over 2. Also then at 3 pi over 2 less than or equal to x, less than or equal to 5 pi over 2. And if I, worked at it a bit, I could, I noticed that, right, I'm adding 2k pi to this from here to here. And then for the negative, that's when I'm between the other parts. So pi over 2 is less than x, is less than, well, and actually I messed up here because I put less than or equal. Those should be strict inequalities. Okay, because the function was undefined actually at those points. And then 3 pi over 2 and so forth. So, we could come up with a formula for this, but at some point it just gets a bit tiresome. And so, we have this derivative, but we need to worry about plus and minus. It's actually not even defined at some places. So this is kind of a nasty one, this number 64.